Turbocharging has transformed the automotive world, evolving from a niche technology in motorsports to a mainstream feature in modern vehicles. Originally developed to boost engine performance in high-speed racing, turbochargers have gradually made their way into everyday road cars, offering improved efficiency and power. This shift has been driven by advancements in engineering, growing emphasis on fuel economy, and the need to meet stricter emission standards. Today, turbocharging is no longer reserved for high-performance machines, but is a key component in making smaller, more efficient engines capable of delivering both power and efficiency. Number 5. Early beginnings. Turbocharging in aircraft and racing. Turbocharging, a revolutionary technology, has its roots in the early 20th century, with Swiss engineer Alfred Büchi being a pioneer in this field. Büchi first patented the idea of using exhaust gases to power a turbine, which then compresses incoming air to force more oxygen into the engine's combustion chamber. This process increases the engine's efficiency and power output by allowing it to burn more fuel with the additional oxygen. The fundamental principle behind turbocharging is the ability to extract energy from the engine's exhaust gases, energy that would otherwise be wasted, and use it to enhance performance. Turbocharging found its first major application in aviation, particularly during World War I and II. Aircraft engines at high altitudes suffered from power loss because of the thin air, which meant less oxygen for combustion. Turbochargers allowed these engines to maintain power in low-pressure environments by compressing the intake air, making them critical in military aviation. This breakthrough significantly improved aircraft performance at higher altitudes, contributing to the success of turbocharged engines in wartime aviation. It wasn't long before turbocharging made its way into motorsports, where the demand for speed, power, and performance is paramount. In the 1950s, turbochargers were introduced into Formula One, and their potential in racing was quickly realized. By the 1970s, turbocharged engines have become a dominant force in various racing formats, especially endurance racing and IndyCar competitions. These engines offered a compelling combination of increased horsepower and fuel efficiency, allowing relatively small engines to deliver exceptional performance. In racing, the benefits of turbocharging were clear. The technology allowed for smaller engines with lighter weight to produce the same or even more power than larger, naturally aspirated engines. This was a significant advantage, especially in endurance racing, where fuel efficiency and weight played crucial roles in overall performance. Turbocharged engines could produce more power without increasing fuel consumption at the same rate, and with advancements in materials and design, these engines became more reliable and durable. Turbocharging thus became a game-changer in motorsports, providing a competitive edge by squeezing more performance from smaller engine displacements. The ability to generate more horsepower from a compact engine revolutionized the design and engineering of race cars, enabling faster acceleration, higher top speeds, and improved overall efficiency. This era marked the beginning of turbocharging's ascent, not just in racing, but eventually in production vehicles, as automakers recognized the broader potential of this powerful technology for everyday cars. Number 4. Turbocharging in production cars. The 1960s to 1980s. In the 1960s, when turbocharging gained popularity in the racing world, automobile manufacturers started investigating the possibility of incorporating technology into production vehicles. The Chevrolet Corvair Monza and the Oldsmobile Jetfire were two examples of turbocharged cars that were introduced by General Motors, which was the pioneer in this field. But these early attempts were hampered by problems of reliability and mechanical complexity, which limited their success. Consequently, they were not very successful. Not until the 1970s, when technological breakthroughs in turbochargers enabled the systems to become more reliable, did automobile manufacturers start to seriously investigate the possibility of incorporating turbochargers into conventional automobiles. Through the introduction of turbocharging, automakers were able to build high-performance versions of conventional automobiles by the late 1970s and early 1980s. By producing vehicles such as the Porsche 911 Turbo, 1975, and the BMW 2002 Turbo, 1973, European automobile manufacturers such as Porsche and BMW were among the first to experiment with this trend. Despite the fact that these automobiles achieved legendary status due to their extraordinary power, they also brought to light a problem that was prevalent during that era: turbo lag, which refers to the delay that occurs between pressing the accelerator and feeling the boost from the turbo. In spite of this, these models solidified the position of turbocharging in the realm of automotive performance and established the foundation for its widespread implementation in more commonplace automobiles. Number 3. The turbo boom, 1990s to early 2000s. A key turning point in the history of turbocharging technology occurred during the 1990s. This decade was characterized by breakthroughs in turbo design, high-strength materials, and electronic control systems. all of which contributed to a significant improvement in the dependability and efficiency of turbochargers. The benefits of turbocharging, such as increased power and fuel efficiency, were more available to vehicles that are used on a daily basis as a result of these improvements, which were paired with the widespread use of fuel injection and computerized engine control. Number 2. Turbocharging in the modern era. Efficiency meets performance. Turbocharging, once primarily used in high-performance sports cars, has now become a mainstream technology in everyday vehicles due to the global demand for more fuel-efficient, environmentally friendly cars. As governments implement stricter emissions regulations, automakers have turned to turbocharging as a solution. By downsizing engines, replacing larger, naturally aspirated, non-turbocharged engines with smaller, turbocharged ones, manufacturers can maintain or even increase power output while reducing fuel consumption and emissions. Smaller engines burn less fuel. Number 1. The future of turbocharging. In light of the fact that automobile manufacturers are confronted with the difficulty of combining power demands with higher pollution restrictions, turbocharging is anticipated to play a vital role in the evolution of internal combustion engines, particularly in hybrid and electric vehicles. These automobiles are equipped with turbocharged engines that are able to collaborate with electric motors in order to deliver instant torque, improve fuel efficiency, and cut pollutants. Additionally, technologies such as electronic turbochargers, which make use of a small electric motor to aid the turbo for immediate boost without lag, are developing in high-performance vehicles and have the potential to become common across a variety of vehicle categories in the near future. This hybridization of traditional and electric propulsion, which is made possible by turbocharging, enables manufacturers to meet regulatory standards while simultaneously delivering high performance and efficiency. This ensures that turbocharging will continue to be important even as the industry progresses towards more electrification. Thanks for watching. Subscribe to the channel and hit the bell icon.